You may put up a 10,000 crore process plant and one small tube failure can starve you of power and steam, and your 10,000 crore investment is lying idle.
Every repeat failure is a management choice. So you rightly said, in coming time with the use of AI, we will be able to identify proactively which area is going to fail.
Those who grow over the third and fourth whys and honestly, brutally address the challenges, they are through.
If industry starts recognizing the importance of identifying the right reason rather than finding who's responsible, because
Paresh, it's such a pleasure to be with you again, and in you I have a friend who is passionate about failure analysis. Let me just tell you that you may put up a 10,000 crore process plant and one small tube failure can starve you of power and steam, and your 10,000 crore investment is lying idle. And if you don't take care of this failure such that you learn from it and don't allow it to happen in future, you have the same fate once again. So today I would like to know from you your views on failure analysis, root cause and failure analysis, and let our friends understand what it is all about. Friends, let me share with you, Paresh is a techie who has converted himself into a very passionate metallurgical analysis, failure analysis, and the most wonderful thing is he has almost done more than 10,000 failure analysis, and it has been compiled and put up as an AIOM handbook. Now we know people who are in the industry, people who are who have the background of technology. We know what it means to have a book published for AIOM. Let me just quickly share with you. Root cause failure analysis is not just investigating failure. There are a lot of things involved in it. How do you prove what is the real reason? How do you learn from it? How do you assimilate the learnings into your culture? How do you go about finding out the real reason, and then how do you implement it for future? So all this is there, and we have the right man in front here. Paresh.
thank you, sir. It is my honor to talk to you on the subject which is close to my heart with personality like you, sir. I remember, I have very technical interactions with you when you just started the foundation of L&T Hazira, and I started the foundation of TCR Advanced, and I came there and you started giving me some important metallurgical jobs. So that created a culture and a confidence in me that Indian industry needs to understand the metallurgical aspect. And you rightly said, sir, that the investigation gives us an opportunity to look back and avoid the recurrence of the serious failures, which has not only economical consequences, as you rightly said. The plant can be not 10,000 crore, but the 80,000 crore or 1 lakh crore. It can be put to standstill by a nut bolt failure, by a pipeline failure, or a pressure vessel failure. So this field in developing countries like India or in a developed countries has the equal opportunity and equal say in improvement. And this subject has a lot of potential to provide industry a great leverage to solve the problems and make the plant safer and more economical productive.
Paresh, let me just give you a quick viewpoint. What happens when a failure occurs? When a failure occurs, several things come into play. The management wants the plant back on an immediate basis. Every day there are millions of crores of rupees. A refinery, for example, would be 60-70,000 crores, a million-ton refinery. And you can't afford a stoppage of one hour, forget about one day. And then you start counting costs. So which are those costs? Is it the cost of losing the production? Is it the cost of replacing that tube or a nut bolt or a pump or something like that? Or is it the cost of manpower and investigation which will be involved? So the costs build up in very, very, very many areas.
Very true, sir.
And when you look at it, the normal answer from the management point of view is stoppage of production cannot be tolerated. So what do? You put up a quick fix arrangement, put something there, start the plant, go back to the management and say everything is fine, and you forget it. And then what happens? 4 months later, the same thing happens. Now, how do you handle this? Your views.
No, sir. When the economy governs the forefront of development, these things are naturally bound to happen. But in my opinion, there are three major aspects which is responsible for this attitude in the industry. One is the timeline, as you rightly said. Forget about days; it is hours which matters in the production loss. So, the person who fixes the problem gets more importance. And this is naturally so because the ultimate goal is governed by the economy. But the second aspect, which is very important, is doing the right skill of investigation. See, skill of investigation is very, very important. As you know, it's not everybody's cup of tea. People try to look at the failures from their experience and they try to correlate based on their limited experience of their knowledge. But ultimately, it must be left to the third person who is not involved in the entire process, where he can bring out the right reason of the failure, which is unbiased. And third, very important aspect is the culture of an organization. See, when I've seen, sir, right from my formative days when I was in GSFC to till today, where I have interacted with tens and thousands of people during these investigations, what culture which we have is the fixing culture. This culture also is promoted by the management indirectly. So the person who wants to question design, a person who wants to question material selection, or a person who wants to concentrate on process improvement is always considered as a hurdle, because it changes the philosophy in which the plant operates. So I think with the advancement in the data processing like AI, this will help and open the eyes of a management, because ultimately we are doing more damage to economy and safety with this approach. So I personally want to see third aspect improvement is the cultural change, and that will bring this knowledge which is gathered over 10,000 investigation giving back to industries.
Very well said. Let me just give you a perspective. I have spent all my life, as you know, in L&T Heavy Engineering, and believe me, it took us better part of almost 15 years before we reached a stage, particularly in heavy engineering. As you know, it's nuclear reactors, nuclear submarines, hydrocracker reactors, ethylene oxide, so many things. And before it became an intrinsic nature to our culture, it took almost 15 years.
But if you are able to do it, sir, it's a great honor for that organization and personal satisfaction to you, sir.
Yeah, but it, as we keep on saying in L&T, you can have assets, you can have people, you can pay 3 times more and get the best people in the world, but there is no substitute for culture. Without culture, there is nothing to win. For example, I'll just give you a very simple, straightforward example. You have a narrow gap seam on a chrome moly vanadium steel continuously being welded for 2 weeks, day and night, and thousands of passes being done. And in those thousands of passes, each pass being around 10 meters, 12 meter long, if there is a 25 millimeter long defect, you have it. How do you repair it? Or you take a nuclear steam generator, there are 50,000 tubes, inconel tubes, and if one tube to tube sheet joint, one pass failed in 2 millimeter of area, you don't know how to go about and repair it. So initially people defend themselves.
Yes.
They have a attitude to project that nothing was done, I did everything right.
But very human, very human.
Yeah, but from there to graduate to an area where you stand up and say that, yes, there is a mess here and I need to correct it and I will learn from it. And there's nothing wrong in accepting that something went wrong. Now, it's a very good sentence. But to put it in practice, when 5,000 people are working and each one of them can make a mistake any point of time during the day, 5 minutes of loss of attention and you introduce a defect, how do you handle this?
No, sir, this is only possible by education, by providing the sense of responsibility, and most importantly, teaching them the consequences of their mistake. So, this is where, people say that the failures are considered to be a learning steps. So, when there is a problem, I think, in my opinion, it is an opportunity to improve.
Yeah.
And that opportunity, if it is being taken in the right spirit, because ultimately we are dealing with human angle. So if they are taught that their mistakes can cost the huge safety consequences, it can take some lives, probably we may get little more attention in the field. But very rightly said by you, sir, that you have to set the culture of quality. Yeah. And that culture of quality can come by recognizing the person who thinks out of the box. Now, these culture brings can come only if the top management is willing to do it. Otherwise, if production is your target, then TCR is always going to be benefited by investigation.
Yeah, true. True, very true. So, one more specific aspect. See, all these failures have also a very important angle of safety, and particularly in process plants. We know of areas, we know of things when seriously things go wrong and there's a tremendous loss of people and assets and all that thing. But I have one very leading question to you. We are now in 2026.
Correct.
And there are laboratories, there are knowledgeable people, there are investigative methods, there are set procedures to take care of RCFA, and so many other things. Is there anything which is not known? So why that all this is not in use?
No, sir. This is a most fundamental question you have asked, because to be honest with you, we are receiving now about 70-80 cases of failures per month to investigate. Now it's adding to my library of analysis. See, it is said that the failures do not occur because of lack of knowledge, but they occur because of the implementation of lack in implementation of existing knowledge.
True.
You rightly said, and that's the reason, sir, we have come out with one system called AIOM, that is Asset Integrity Optimization and Management, wherein the multidisciplinary activities, because why failures are not being pinpointed, because the process person will say this is not our problem, the maintenance person will say it is not our problem, the quality control person will say not our problem. Designs, mostly they come from the licensors, so people cannot question the design in total. But let me tell you, sir, by doing investigations, we have improved these foreign licensors at many locations. And now they are asking our clients that what the investigation agency TCR is telling about this. There is a constant improvement process. But you are right. In 2026, I'm sure in coming 3, 4, 5 years, when people will use the asset management integrity programs, the failures will be reduced. I will not say it is going to be eliminated, because there is one word which is known as act of God, where sudden disturbance in the earth management occurs by earthquake or a very heavy wind where the components are not designed. So problems will occur, but the man-induced problem which can be avoided. Because I have seen plants, sir. I have witnessed one boiler which was manufactured in 1935. Mm-hmm. And I did the residual analysis of that boiler in 2005, and I gave another life of 10 years.
Wow.
Now that boiler was a Stand-Muller boiler, which was, in those days, welding technology was not at the forefront, so it was a riveted boiler. The reason of the retirement of the boiler was efficiency. So intention of understanding is the safer design, the safer material, and what is ultimately economic life cycle of a component from the investigation that we must address. And I am quite hopeful because we have now got our first opportunity to put this asset integrity system into the operation. Once this starts, because I don't want people to learn from their own failures. There are so many other failures which has occurred in the industry. So you rightly said, in coming time with the use of AI, we will be able to identify proactively which area is going to fail.
Yeah. So I recall the other day when we were meeting, and of course this point you put it so very articulately. The three reasons for time, pressure, capability, and culture. Why not you elaborate for our friends? Time, pressure, capabilities, and culture. I mean, those are the three factors you felt prevent or enable the use of the latest things available to them.
No, you're quite right, sir, because the best thing, I earlier explained to you about these aspects, but I will elaborate on those points. See, time pressure is something which is going to be on everybody's head. But I want the top management or the stakeholders to understand and look at those incidents which allowed the factory not to start till 6 months. So sometimes saving in 1 day or half day may put the entire plant into the system where the loss of economy, loss of safety, plus loss of reputation. The consequences of hard timelines are very, very. It is like you are driving in a hurry or from one place to another place. If you have reached, you think you have achieved something, but if you are not able to reach because of some accident, then you will regret this decision of speeding throughout your life. So I think I would like to compare these with the timelines. The second thing is the capabilities. I've seen many industries, they have a lot of capable metallurgists, those who are there in the industries. But the problem with the in-house metallurgist is that he is always bound by the rules of the company, always bound. His hands are sometimes tied up not to talk directly on the problems because of the XYZ reasons. The capabilities point of view, and many industries, they take the third party views on the investigation. But very important aspect is that people don't preserve even failed samples properly, sir.
Oh yeah.
So what happens, in order to meet the timeline, people just cut the sample and just leave it there. Now, people don't understand that this is like a post-mortem, it's a black box. The fracture surface of the failed metallic sample has a huge evidences. Any corrosion product which can be contaminated through environment also has a huge consequences on diagnosis. So this aspect also has to be correlated with the capabilities of the investigation. If you don't have, fine. The moment you have the component, just put it in a proper plastic bag and don't put it under your legs. Put it at somewhere which is visible, where you can learn from it or you can do for investigation. The third aspect, which you talked about, the culture. Yeah, you see, culture of the organization will most importantly improve by education, because in metal there are more than 85 damage mechanisms which occurs. Yeah. Now, a mechanical engineer is never taught about damages. A metallurgical engineer is never taught about the mechanical engineering, which is the mother of engineering. Let me put it this way. Yeah. Metallurgy has a huge capability to facilitate the vision identified by a mechanical engineer or a process engineer.
True.
So this is an interdisciplinary activity, and I want to see the sandwich program after engineering. Like, we have put an institute called Evolve, where we have trained more than 3,500 engineers, practicing engineers in the industry, where we try to give this knowledge interdisciplinary. And this interdisciplinary knowledge will increase the capability within the company. The first capability, sir, it will develop is that I don't know.
Yeah.
And I don't know is a tremendous knowledge.
Yeah. You say it so well. when the culture allows you to stand up and say that I do not know this, that's the first admission to people that yes, you need to know more.
Yes.
It's a fantastic way to look at it. Okay, so I'll share with you our own experiences in L&T Heavy Engineering. We continue to have a very different type of cultures. Many times the work comes to us which is the first time. For example, fast breeder reactor, sodium cooled, or PFBR, or
Defense.
For example, when we did the nuclear submarine hull, the first thing which we did was the nuclear submarine hull was a B2. We did a mock-up of one section, the nuclear reactor section out of HY. They're totally different material, but the Russian materials were not available. So what was the thing? I'll just tell you, why am I elaborating it? Nothing was available, completely ready, implemented, and for you to implement. No. You have to continuously improve. Every day you have to make mistake. Every day it's like a hurdle race. Morning, evening, you again sit back and say, now this has happened. What do? And don't take the attention away till there is a reasonable solution. Do the practices, prove that it is right, and then take the next step. What is the ultimate, Paresh? Ultimate is, in those days, the job was 42 crores. For us to, the sale price was 42 crores. And we ended up spending 56 crore on that job.
My God, learning cost.
But the credit goes to our culture in L&T. My chairman used to say that everything that you learned here will give you 10 times more profit in future. You develop new technologies. And believe me, in my rather long engineering career,
a long inning.
This has always been true. Everything that you develop paves way for more money in the next job.
Wonderful.
So when you have this, why you are a student of this discipline, we have practiced, blundered through, but time has come for you to tell us what is the methodology for proper root cause analysis.
Yeah, no, you're right, sir. See, now with all this discussion,
you were talking about 6 phases, if I recall correctly.
Yeah. So, when we are talking about the, methodology of the investigation, sir, the most beautiful methodology which I have come across is 5 times why. The why analysis is something which has really improved the failures in any part, including metals. So let me give one example. That one bearing is repeatedly failing, and when you ask the first question, you will say the bearing got overheated. That's what first why. The second why will tell you that why bearing got overheated. Then you come to know that there was a lack of lubrication. The third question is why there is a lack of lubrication. So you will say that there was some choking which has occurred in the lubrication system, which did not allow the proper lubrication to follow. The fourth question, why choking occurred? So that there is no maintenance system for this lubrication. So fifth question is why there is no management system? Because there is no culture of learning in proactive manner. So ultimately, those whys will lead you to the right root cause. This one root cause is an apparent root cause. The other root cause is the latent root cause.
Yeah.
So the latent root cause is something which in industry needs to do that. There are many methodologies to do investigation by fishbone diagram. You can find out different possibilities. Then there are McKinsey's curves. And there are many methodologies which is there available. But first and foremost, when I talk about the metallurgical root cause analysis, because it is very important to investigate the reason, because it can identify design problem, it can identify manufacturing problem, it can identify welding problem, it can identify maintenance problem. So these center of the investigator is a metallurgist, because metallurgist can speak the language of metals. and metals can record the use and abuses on the surface.
True.
So, when any failure occurs, the first and foremost is the site visit. In today's time, if more economically, it is not always acceptable to call experts for every failures. In that time, you can go to the site and take a video and submit it to the expert, which is second best option. The third important aspect is collection of background data and information.
Yes, very true.
I have always seen, sir, when there is a failure, people are reluctant to share information.
True.
Because there is a fear in the mind that they will be made responsible for these failures. So getting data, so management must openly say that when you go to a doctor, please provide all the information which is needed to investigate. So this is second aspect which is very important. Third aspect.
Yeah, I think you very, very, very well pointed out. It's very important not to disturb the evidences.
Yes.
Collect them, preserve them, so that the right amount of attention is paid and the learning is extracted out of that. I completely agree with you. In fact, evidence is the real issue. And coming to the very beautiful point that you made about 5 whys, and you also concluded it very well. See, what is our experience is after third or fourth why, you realize that your policy was wrong. You realize that management did not train the person. You realize that the management punished a person who made a mistake. So after third and fourth why, most of the organization falter. Those who grow over the third and fourth whys and honestly, brutally address the challenges, they are through. That's the road to heaven.
Absolutely. So that's the reason, sir, we say failures are not hurdles, they are opportunity.
Yes.
for the next improvement, sir. So and this subject has given me a wings in the field of engineering. I've learned how turbine operates, how turbine blades are designed, how compressor operates, how pressure vessels are designed, how pipes are made, how manufacturing is done. So doing so much of investigation has given me a panoramic view of the entire engineering aspect. And believe me, sir, I believe honestly that any plant can be made failure safe.
Yes, very true. You were also speaking about after the evidence is collected and preserved, that is the time you get into various examination mode, physical and all that. Can you elaborate on that?
Yes, sir. Now, the important part starts when the sample receives at the investigation center. The careful visual examination, and in today's time, we have fantastic aid. Sir, you will be happy to know that in our days, the magnifying lens was considered to be the ultimate magnifier with you. And after that, microscope and electron microscope. In today, the Japanese technology has brought the digital magnification. And you will be surprised to know that, sir, it can go to 10,000x digital magnification.
Wow.
That has given us huge power because, we are trying to look what has gone wrong. Sometimes one copper particle gives you the clue that a catalyst somewhere is getting leached and doing the copper embrittlement in the steel.
Very true.
So so we try and investigate the evidences carefully crafted. After visual examination, low magnification examination, then you do fracture study, and then you try and find out the origin of the failure. Once the origin of the failure is identified, you put under electron microscope, find out how the features are there, whether it's a ductile, brittle, or a fatigue, or a shear, what are the evidences. Those evidences are then correlated with the actual operation and design. So it's a multidisciplinary activity. In my team, I have 9 Ratnas, which are all 9 disciplined people are there.
Yeah.
Whomever is needed, we contact them and identify and support the investigation. I always say, sir, that the right investigation of a cause will answer all questions.
Very well said, and I really appreciate you brought a lot of clarity. And I would guess after the tests and all that, then you have the data on your lab, and you need to do you need to apply structured analytical methods. That is the time you would cross all the boundaries of your protective, regressive behavior and move into an area where correct hypotheses come up. Your views, please.
Sir, you are quite right. Many times, the flip side of investigation is that when you see the sample, you have some hypothesis created in your mind. Now, human brain is designed in such a way that whatever you have perceived, your intellect will work to protect your perceives.
Yes.
So you try to look for those evidences which you have already decided. Now, this is very important mindset for an investigator, to come out and look neutrally. Every evidence tells you why this has gone wrong, but only one evidence that, sir, this plant has never seen stoppage.
Yeah.
Now, all your hypothesis crashes with one statement from the plant. Now, if you don't give importance to this and doubt that sentence, you are away from the right root cause.
Yeah.
So that journey of building the true investigator in the area of investigation is self-learning, stopping your mind, keep an open mind, and answer all questions.
Yeah. I think you put it so very well. Now, this is where the point which you are making, that structural analysis is, one is yes, good intent. Second is very honest acceptance of the feed that is coming.
Correct.
If you are an all-knowing great guy and skeptical about everybody else's views, then I wonder how will you do Y wise, 5 wise, or I wonder how will you do fishbone diagram or fault tree analysis. Those are all challenges whenever you are faced with a failure analysis. So I want your views on that.
No, sir, you are absolutely right in identifying the. Now, it's a question of your openness to the system. See, let me give an example, sir, that stainless steel components fails left and right. And now, since people have known that it is because of the chloride, people always look at the culprit as chloride. But the chloride is not always the culprit in stainless steel failures. Even ASTM, who has made the specifications, and we all follow them like a god, because they have been the pioneer in this area in putting the material into practice. It has also a limitation that it doesn't allow you to accept the upper limit of UTS and the how much it will only tell you the lower limits of requirement of UTS. Now, cold working is a serious matter. When you do work with stainless steel, austenitic stainless steel, sir, this cold work can be overly incorporated into the material. I have seen cryogenic vessels failing because of the gaps in the specification. So now, if I feel that whatever ASTM is written is like a god, then I will never do the correct investigation.
Very true, very true.
That's why even world-renowned specification companies, they come out with new specification every year. Because this is learning process for them also.
Very true, very true. Very true, very well said. So, because you mentioned so many methods, one of the methods that we had to use during the thermonuclear fusion reactor components that we made, the cryostat and the inner chambers. And one of the things, the customers, the customer was an international body, and then one of the things they'll say is, okay, you make this particularly in this particular method. How many ways it will fail? Now, when somebody asks such a leading open-ended question, you don't know how to answer it. But when you figure out how to answer it, that is the time FMEA really comes into place.
Absolutely.
That means you would prove that there are 6 ways it can fail. And believe me, our experience is, when you investigate those 6 ways, you find out another 60 ways it can fail. Then it frustrates you, and at the end of the day you say, but then if you persist, and finally got through that, let me tell you, you come out with such wonderful procedures which satisfy you and which adds value to you. And believe me, that is your future profit. So tell me about the fourth stage. How do you work out a hypothesis? Okay, you did all this, you applied FMEA, you applied fishbone, you applied 5 whys. End of the day, you'll have to say that this is the hypothesis, and all the observations, all the evidences, all the analysis, all the investigation lead to this. Now tell us about that. You are the person who has done it 10,000 times, and now I want you to explain to my friends.
No, sir, the developing an hypothesis in an investigation is the most critical step during entire investigation, because the testings and results and data which is there with you. Now, your concepts on damage mechanisms are very important. For example, let me give an example that a crack can occur transgranular or a crack can occur intergranular. At room temperature, grain boundaries are stronger than the grain. At high temperature, grains are stronger than the grain boundary.
Yeah.
This temperature is known as equicohesive temperature. I'm giving you a little technical background to understand the hypothesis. Now, all the data which tells that temperature has not gone beyond 500, but you see intergranular fracture, not stress corrosion cracking, but intergranular fracture. Your hypothesis is based on your metallurgical fundamentals, will never go wrong. All data can provide you, can have gaps. That's why investigation, hypothesis and data analysis is most important. The moment you say that there is an intergranular fracture, which means locally there is a temperature increase. Not the system will find you, but local temperature increase. Now that is where your hypothesis comes, and you should have that courage and guts to put against the data provided by the client. And that is where when your hypothesis proves correct, you generate trust in the mind and heart of the client. This is where hypothesis understanding is most important, and it should be derived from the understanding of damage mechanisms.
I agree. Very, very, very well articulated. And see, a hypothesis will also require us, and you in particular, to point out areas where things have gone wrong, people who need to take care, and you have to, at that point of time, you have to cross that cultural barrier for people to accept that this is a hypothesis which applies and we accept it, and that will lead you to conclusion. How do you manage that?
Can I give one practical example here?
Yes, please. I will tell you that's the most beautiful part of this.
There was one header of a power plant which used to fail during every startup. Whenever there is a failure, the startup will give problems, and then somehow they used to manage and run the plant. But there is always a failure during normal startup. So the sample came to us, we investigated, and we provided that there is a fatigue crack which is propagating. Now, plant people had backup from their original supplier of the equipment. They ruled out this possibility. So we were in a loggerhead. I received 3 samples in 1 year. 3 set-downs were there. Every time I wrote bluntly what was the reason. Then the problem was not getting solved by them. Then one day we went there for a site visit. And when I could find out that when during startup the temperature increases, the header was not provided proper space to expand. There was a restriction which was coming on its way, which allowed the stuttering, you can say that vibrations increased because of that particular, when you overcome, it will go. So when after 2 years, when I recommended clearly to them that you please go for the stress analysis of this header. And they did FEA analysis, they did every CFD analysis also. And they could find out that the only one support which was there needs to be little kept away from its own position. The problem disappeared.
Oh.
Now that company, initially, they were ready to put us into blacklist because they think that we are misguiding them. So there is creating an hypothesis based on the fundamentals also needs your conviction to put every time. It needed guts to write the same reason 3 times, in spite of them telling that this is not the right reason.
Paresh, I remember sometimes back you were telling about a clad elbow, and it had those fatigue cracks, and you finally traced it to the operating pressure incursions. You remember that?
Yes.
That was an interesting observation. I mean, interesting investigation. And I'm telling you, no wonder you will be blamed for leading the management in the wrong direction. But
yes,
ultimately you were proved right.
Yeah. No, thank you. So,
can you recall that nice?
Sir,
it was about a refinery elbow, clad elbow.
Yeah. See, the component, when you investigate, the fracture surface of the elbow tells you that I was abused by vibrations. I was abused by temperature fluctuations. I was abused by not having proper passive film. So, investigator has to talk to the failed samples in a literal meaning, because you do not, a sample will give you the evidence.
Yes.
But you have to understand. Now, the second level of expertise an investigator should have is to correlate the process parameters with the observed damages. So in that case, sir, there was a very clearly written pattern of the thermal fluctuations. And what happens, people always look that my process parameters were normal during operation, but they forget that during startup and shutdown, more vibrations and fluctuations comes.
Very true, very well said. So it's a classic case of walking into areas of operations and not all the time blaming components.
Yes.
So fine, we finally worked out a hypothesis, worked out a conclusion. But let me share with you, and you will probably know better than me, is many times for the component which failed, the analysis is very important, you solved it. But that's where is your knowledge asset, and that needs to be used in future.
Yes.
So in our case, in L&T particularly, if you have not made a report, if the report has not been properly vetted by people who can articulate it, because great technologists have great insights into failure, but many times they do not have the right literary words to articulate the issues. So sometimes the reports are too cliched, too complicated, too jargonized. So how do you convert your conclusions for your use future? As I would like that type of failure should never occur again in the industry, and of course in your own organization. How do you handle that?
Yeah, so I always say this, that please learn from the other's experience. Number one. Proactive approach is always better than the having a failure and then learn. So in order to go for the proactive approach, we must identify the present damage mechanism and future damage mechanism. Now that understanding of damage mechanism will come by doing the systematic analysis of every component. Like for rotating component, it is FMEA. For static components, there is methodology which is provided by API is risk-based inspection. The third methodology is knowledge-based audit. You can always do knowledge-based audit in the plant and industry. So there, or you can implement the asset integrity and optimization system in your company by doing the systematic analysis of the what can go wrong. So now that data is available. Industry has already given that opportunity to people like us, wherein we are able to foresee where problem will come.
Yeah.
So now that it is time to put them into the bundle and make them in such a recipe that for that component they can get only those details which is needed for them.
With codification, so that easy accessibility.
Easy access. That is where I believe we have made a difference in the industry, that today we are able to, in emergency, we are able to give investigation report in 24 hours.
Oh.
When a plant is running and having failure, the sample is sent to us in a flight from Middle East, from different part of the country. They come sample to our laboratory, people trained to work for 24 hours. Because of our depository of knowledge, we are able to identify the reason and they are able to take corrective action in the same shutdown. Now, this is probably nowhere in the world this is possible.
That very, very rapid response.
With accuracy.
Yes. But that's because you're sitting on a huge knowledge base.
Correct.
I mean, there are how many organizations will do 10,000 failure analysis across the geographies, across the industry sectors? I mean, that's very unique, and no wonder your ASM contribution of the failure analysis is very unique and a real value addition to the industry.
Well, Trivedi sir, coming from you, it gives me more encouragement, because when we grew up, we looked up upon you as my alumni from the same college. I've attended your lectures, sir, and those have inspired us to do these things. But you're quite right, sir. We have done another 50% of our work. My dream is to see that the industries become fail-safe, and I'm sure it can do that, provided through 3-4 things which we discussed in our podcast discussion, sir, which will help our viewers to, because today's engineer is going to be tomorrow's decision maker.
Yes.
And whatever decisions we will going to take, it will help industry to have the fail-safe operation.
Now, can you share with our friends how do you build genuine RCFA capabilities? Because I know that's your passion.
Yeah.
Because I mean, we don't see you as a person who gives you answer for things which fail, but it's also a person who is ready to build the organization's capability to do genuine RCFA. Your views, please.
Yeah. See, root cause failure analysis concept, if industry starts recognizing the importance of identifying the right reason rather than finding who's responsible, there's one change which we need in the management circle. And the second point is that the knowledge label person can operate a plant in a quite safe manner, but unfortunately that person has a limited time to service, and these limited time will take the knowledge with that person. So the second point is the knowledge can be retained in the company by proper systemization of the data and knowledge. This is something which is industry needs to do. And the third and foremost is bring the cultural change. I'm very impressed the way you indicated that, we should develop the culture of courage in the company, that, okay, this was a mistake. And, it should be viewed as a sign of improvement. Probably the person will become like a tiger in his approach and will not allow such things to happen by even others also. So that's what I believe.
Yeah. Now, that brings us to AIOM platform.
Yeah.
Please tell us about that.
Sir, Asset Integrity Optimization and Management, AIOM platform, is built by TCR Advanced based on the knowledge which has been gathered over vast amount of investigations. We have done investigations from orthopedic implants to the space components. The spectrum involves everything. Because, when I was young, I read one advertisement from Tata Steel that there is a little bit of steel in everybody's life. And then that gave me a confidence that I am not in a wrong line, because I will get. And then that proved so true that metals are the integral part of the human race, and they are going to be the one of the strongest part. So in order to make the human safe and economically durable, it is very important to understand the metal, the way they behave. And in order to do that, the knowledge which is already gathered should be put into prevention. So this AIOM has a very structured and systematic approach. For example, if you take one vessel or one pipeline or one compressor or one column for a static equipment, then you try and find out where things will go wrong based on the operation parameters, based on metallurgical construction codes, and then you make a proper inspection plan. And then one important point, it is said that over inspection does not increase the safety. So right inspection with right technique at right time, that is the beauty of this system, and it will leave the equipment which is not needed for inspection.
Yeah. So I want to finally ask you, when should a plant call in external expert? Please give us clear guideline. I mean, I have a plant and it's running well, and yes, there are people who are running it and problems are being solved by maintenance and somehow it's running. But when is it the time to call experts? What is your advice to people who are listening to us?
See, the right time to call expert is when the plant is running normal. Because when plant is running normal, people are at ease to perceive what can go wrong. Let me give an example, sir, here. An operation guy is more open for the changes or for providing the data when there is no failure.
Yes.
So this is the time where external agencies should be called. They should identify the areas of concern, get audited whether your practices are right, find out the gaps between the training need in damage mechanisms, which I see there is a huge gap in the industry today. That is why I see a lot of failures which are occurring, because everybody has their own view on the failure, which may or may not be right.
True.
Unfortunately, if you are on a higher rank in the company, you will be proved right.
Yeah, that's culture part.
Yeah.
Very
So these things are very, very important, and I want people to call experts when things are normal.
Yes. Yeah, Paresh, it was wonderful to listen to your insights. Your depth of experience was very evident. Now, my friends in the audience would like to know those 5 takeaways which they can take home, take back to their work, direct and clear. Please.
Sir, every repeat failure is a management choice. Whether you want to live with temporary repairs, or whether you want to do the repairing, or you want to reduce the pressure and run, it's a management choice. But rather than addressing the symptoms, if the management chooses to address the cause, this is something which will eliminate the failures forever. This is my first point. Then in the first point, treating the symptoms, when I say, I would like to elaborate in the second point. For example, I have seen people upgrading the material without understanding that upgraded material has a lower life in the given situation.
True.
People feel that when you increase the number of the series, the better material will come. So that aspect should be left to the right expert and judgment rather than treating by your own understanding. This is number 2. Then third is physical evidences are most important aspect on the investigation, where that needs to be properly understood by the top management to the bottom, that what sample is saying, which I gave you an example of the fractured, and then it was correlated to the local temperature rise. So this is where the physical evidences on the sample should be kept as most important aspect. Root cause failure analysis must be a procedure rather than personality oriented concept.
Yes.
Because I have seen in many industries, if the top management changes, suddenly the investigation work reduces. Because the philosophy feels that couple of failures are accepted.
Yeah.
And somebody will feel that, no, why even couple of failures? So that aspect of going into the root cause should become the procedural and cultural related aspect. That is the other intact which I want to
Very true.
tell you.
That is quest for excellence.
Yes.
Yeah, very well said.
And over the time, I want organizations to build RCFA capabilities on their own, because what happens is when you start building your own capabilities, you try to learn about the damage mechanisms, you try to learn about your unique processes, because there are many processes where the details are not disclosed to the people as a third person. So in such cases, when you have your in-house development capabilities, it will help you to run your plant safe. These are my points and takeaways from this podcast.
Paresh, really thank you. You have been very articulate. I'll just narrate one very small instance and then strengthen what you've been saying. So let me just give you an interesting insight into what we go through. We had to make some very critical equipment for this fast bidder, Bhavini. And there were very elaborate specifications. Very knowledgeable people had drafted it. And the data sheet, the drawings, the specifications were very meticulous. But when we go into details and when we speak to people who are experts in those areas, we realize that their intention for that system was not correctly conveyed in the drawings and specs. So while as L&T we were doing our best to meet the drawings and specs and data sheet, it was still not meeting their worries. So how do you handle this? So we discovered that you sit with them, interpret the specifications and all that, and list down their worries. Their worries are probably not articulated, but they are the great steps forward for future. So, which is what you captured it, that don't just go by, I have met the specification and forget about the rest of the thing. It doesn't work that way. There are millions of instructions and operational details and other things which are non-written, and it has to become part of your culture to interpret them and inbuilt into your manufacturing procedures.
Correct.
Yeah. Really very nice. Thank you.
Trivedi sir, it was an honor.
Yeah.
And I think we will be able to have the fail-safe plants.
Thank you. Thank you. God bless you.
Thank you.